All right, so when we're doing optimization problems in calculus, what we first want to identify is what the primary equation is. And the primary equation is what you're trying to maximize or minimize. So in this case here, we're trying to maximize the area of the red rectangle. So let's call the area, and let's just say length times width. Okay. Our secondary equations are going to be what we use to sub into the primary to get it in terms of one variable. So if I look at this rectangle here, I can see that the length of the rectangle would be equal to 2x's on each side of the y-axis there. And I can see the width of the rectangle is going to equal the output value, which in this case here would be the y value, which would be equal to cosine x. So what we want to do is we want to sub in L and W in terms of x here. So we're going to get the area is equal to the length would be represented by 2x, and then the width would be represented by cosine x. Okay? So what we want to do is we want to maximize the area. So what we're going to do is we're going to do A prime. And then in this case here, we're going to use the product rule. So that would be 2 times cosine x and then minus 2x times sine x. Okay? And what we want to do is we want to set this equal to 0, and we want to see if there is a relative min or relative max. So if we set this equal to 0, okay, now this is a calculator active problem. So what I'm going to do is I'm going to show you desmos on the screen here. And if we solve this using desmos, we can see that the derivative changes from positive to negative at x equals 0.860. All right? So that means that my x value is 0.86. So if I go back to my original area and I plug in 0.860, I'm going to get an area of about 1.122 units squared. Okay? And we would have to identify that x equals 0.86 is a relative max because it changes from positive to negative at that point. And once we have that and we know that, we can plug that in and we can get our area. Okay? Hope you liked the video. Thanks for watching. Please like and subscribe.